Today we will learn how to use the Pythagorean theorem to find the distance between 2 points on a coordinate plane. You should be on page 31 in your notes packet. The first 2 points that we want to find the distance in between are -6, 1 and -2, 5. Before you start, you first want to actually put these points on your coordinate plane. So I know that my ordered pair always starts with an x value first, followed by a y value, and x tells us whether to move left or right, while y tells us whether to move up or down. Since our x value is -6, then I would start at the origin and I would move left 1, 2, 3, 4, 5, 6 units. Because the y value is +1, I'm going to move up 1 unit. So this is point -6, 1. Then I also need to plot point -2, 5. So again, -2 is going to be my y value. And since it's negative, that tells me that I'm going to move left 2 units. And then my y value is positive, so I'm going to move up 1, 2, 3, 4, 5 units. Now I need to find the distance between these 2 points. A common mistake that is made is that you want to count from here to here and say that this is the distance. However, that is inaccurate because the diagonal length is not the same as the vertical length or the horizontal length of one of these grids. Instead, we can take our points and we can find the distances that we know that are perfectly horizontal and perfectly vertical. And we can use those to find the distance between these points. So we know that we're looking for this distance, which is what we do not know. However, if we come down here and drop a perfectly vertical line from this point, we do know this distance. Because this is a vertical distance, we know that we can just count, and it's 1, 2, 3, 4 units on the coordinate plane. Then I would figure out what is the horizontal distance here. So what would be the distance from here to here? Well, if I start here, it's 1, 2, 3, 4 as well. The question is, what is the actual distance between these 2 points, which is this value here? Well, because this was perfectly vertical and this was perfectly horizontal and they met each other, then we know that they actually met or intersected at a right angle. So we can use the Pythagorean theorem, and what we're missing here is going to be our hypotenuse. So when we plug this into our a squared plus b squared equals c squared formula, we know that both a and b are our legs, and both of our legs happen to be the same value. So they are both 4. Well, I know that when I do 4 to the second power, I'm going to get 16. So I have 16 plus 16 equals c to the second power. And when I add 16 plus 16, I get 32. Well, I know that I'm not done. I have not actually found the value of c. What I found is the value of c squared. So to get c by itself, I'm going to need to use the inverse operation, which is taking the square root of both sides. The square root of c squared is c, and if I needed to get a perfect exact answer for this, then I would want to simplify this because I know that 32 is not a perfect square. Well, the greatest factor of 32 that is a perfect square is 16, so I could rewrite it as the square root of 16 times the square root of 2, because 16 times 2 gives me 32. Well, I know that the square root of 16 is 4, so this is 4 times the square root of 2. If I needed to know an approximate answer, I would just put it in my calculator for the square root of 32. And if I did that, I would get approximately 5.7. For most of these values, though, you are typically expected to find the exact answer unless you are told to round to the nearest tenth place. Now let's try 8, 7, and 5, 3. Again, we have to plot our point first, so we're going to plot the point 8, 7. So we'll move right 8 units, 1, 2, 3, 4, 5, 6, 7, 8. Mine actually goes off the grid. And then up 7 units. So 1, 2, 3, 4, 5, 6, 7 units. So there is that point. And then we need to find 0.53. Well, that's right 5 units. 1, 2, 3, 4, 5. And then up 3 units. 1, 2, 3. So that puts us right here. Well, again, we need to find this distance. So what is the distance from here to here? Well, you can count this and you can say, okay, what is this horizontal distance? Well, I know that the distance from here to here would be 1, 2, 3. So I would put 3 here. And then I want to know my vertical distance here. Well, this is 1, 2, 3, 4. So this is 4. What I'm missing is my hypotenuse. So I'm going to plug in for my legs, which are 3 and 4, and I'm going to find my hypotenuse, which is my missing value. When I have 3 to the second power, I know that that equals 9. 4 to the second power equals 16, and then I have equals c squared. When I add 9 plus 16, I get 25. So 25 is equal to c squared. Well, I need to take the square root of both sides of this equation, which leaves me with c equals, and 25 actually is a perfect square, so this is going to give me an exact answer, and the square root of 25 is 5. So that means that the exact distance from between these 2 points is 5 units. Now let's try -9, -3, and -3, -6. For -9, -3, we would need to move 9 units left, which again goes off my grid, sorry. And then down 3 units, so 1, 2, 3. So this is -9, -3. Then I need to go to -3, -6. Well, that is 3 units left, and then 6 units down. So this is -3, -6. Well, my question is, what is the distance between these 2 points? Well, again, we're finding our horizontal and vertical distances. So we need to know these 2 distances right here. Well, I know that this distance is 1, 2, 3, and this distance is 1, 2, 3, 4, 5, 6, because mine actually went off 2 spaces. Well, we know that these 2 connect at a right angle, and we're missing our hypotenuse. So we're going to plug in 3 to the second power and 6 to the second power for our legs, and we're missing our hypotenuse. 3 to the second power is 9, and 6 to the second power is 36. When we add 9 plus 36, we get 45, and so we have 45 equals c to the second power. Well, we need to get c by itself, so we need to find the square root of both sides, which is going to leave us with c. Now 45 can be simplified, but it can't be found the exact answer because it is not a rational number and it's not a perfect square. But we can find the factor, the greatest factor that is a perfect square. And for 45, the greatest factor that is a perfect square is 9. So we can rewrite this as the square root of 9 times the square root of 5. We know that the square root of 9 is 3, so we're going to leave this as 3 times the square root of 5. So that would be the distance between these 2 points. Next, we have 3, -2, and 7, -8. To get to 3, -2, I would move right 3 units, and then down 2 units. And to get to 7, -8, I would move right 7 units, and then down 8 units. Well, I need to know the distance between these 2 points, so I'm going to find their horizontal and vertical distances. So I know that from here to here, this is 1, 2, 3, 4 units. And then from here down to here, this is 1, 2, 3, 4, 5. And I have to go off the grid 1, so that is 6 units. So again, we have our legs and we're missing our hypotenuse. So when we plug this into our formula, 4 squared plus 6 squared equals c squared. 4 to the second power is 16, and 6 to the second power is 36. Well, when we add 16 plus 36, we get 52. Well, then we have 52 equals c to the second power. Well, we know we need to get c by itself, so we're going to find the square root of both sides. Again, 52 is not a perfect square, so we're just going to have to simplify it. Well, when I think of 52, the only factor that 52 has that is a perfect square is 4. But I can rewrite this as the square root of 4 times the square root of 13, since 4 times 13 gives me 52. I know that the square root of 4 is 2, so this becomes 2 times the square root of 13. So the exact distance between those 2 points is 2 times the square root of 13.